Hi everyone, and welcome back to Pardersline. Today, I want to make you an expert in 3D segmentation. We are going to take in input an original point cloud of a chair and to get using a PointNet deep learning model, the final segmented chair with 4 classes, 4 labels, one for the seat, one for the legs, one for the back, and one for the arms. So let's go ahead with the code. Here we can see the segmentation config, and inside we can find the name of the classes, back, seat, leg, and arm. We can see also the URL of the point cloud to download, share.pts. And also we can see the model URL where to find the model is a PyTorch model, which is a PointNet model, and the termination is Onyx. It's like a PyTorch model with another way to save this model. So let's continue now. We can see that the model accepted as input 1, 3, and then the number of points, and output should be 1, the number of points, and 4 for the number of classes. So what would be necessary in order to apply the inference to our original point cloud? It will be necessary to first load our point cloud and then to apply a pre-processing. Let's see that. So now, how many points do we have? So we have 2776 points, and it's already normalized. As you can see here, point cloud normalized, centered at origin, max distance 1. And you can see here the max is 0.79 and the mean is minus 0.79, and we have exactly 3 coordinates for x, y, z. You can also note that we don't have the normals of the point. It's not necessary for using PointNet model. Then let's go ahead. So let's visualize it. We have here our chair in 3D. We can click on plus to make the points bigger. And if I click on N, I don't see the normals because I don't have them. Now let's see the pre-process for inference, and let's see how what we get after the pre-process for inference. So now the input data, so the points was 27 and 76 and 3 coordinates, and now input data is exactly the same, but now we have 1 for the batch. So what we did exactly, we did transpose between the 3 and the 2776 to get the 3 before and then the number of points. We also added a dimension for the batch, which is 1 here. Before continuing to present the code, let's see what is exactly PointNet model and how it's working. The PointNet model is this architecture. So it's taking as input n times 3 for the number of coordinates. So let's say in our case, we have 2776 number of points and 3 coordinate x, y, z. For the classification, the output will be only k for the class, okay? And for the segmentation, it will be the same number of points, okay? We have n at the beginning, we have n at the end, and m is the number of classes. So the main component, we have several main components in the PointNet. One of the main components is the TNet. The TNet is performing a transformation to get the original point cloud in a canonical space. At the beginning, we have only 3 features. After that, we have 64 features, and then we make again the transformation TNet to make it in the canonical space and to make sure the point cloud will be aligned, exactly aligned. Then after that, we get here the local features, and to get the global features, we go through max pooling, which is a symmetric function, in order to get the points invariance to order. It's very important for the PointNet, invariance to rotation by the TNet, and invariance to order by order of points by the max pooling symmetric function. Then we get the global features. It's enough for the classification, but for the segmentation, we need first to concatenate the local and the global features to have in total 1088 number of features, and then to get also shareable MLP, which is a multi-layer perceptron, 2 times, and get at the end the score for each single point. So here we have m classes, and in our case m equal to 4. Let's come back now to our code. So run inference. Let's go inside. So to run the inference, we need first to use the last layer, so compile model output and 0. So this is the last output layer, and then we just insert our input data and we get the result. It will be interesting to see what is exactly results. Okay, so this is our result, and we can see the shape is 1, 27, 76, and we have 4 for the 4 classes. Okay, this is for the result. Now we can take that. Let's take like the first one, 2 first rows, and you can see, for example, the first row, what would be the predicted label. Here we have almost minus 12. Here we have minus 10. Here we have minus 0.00002, and here we have minus 8. So what is here the maximum of all the 4 examples or all the false probability classes? This is the number 2, 0, 1, 2, because here is almost close to 0 when the others are completely negative. So let's see the predicted labels. We choose argmax, predicted labels. And now we can see that the first one is a 2, as you just demonstrated. So let's now continue. Now we can compute also the stat when the stats provide to us an explanation about the number of points per classes. So we have here almost 1,000 points for the back. We have 785 for the seat and for the leg, etc. And we can see also the percentage, which is very interesting, that the back is the most. Okay, when we saw the chair, the back is the main part of the chair, so it makes sense that we have 34% of the points assigned to this label. Let's now visualize the results, and this is our final results obtained by using PointNet deep learning models. It's a great result. That's it for today. Thank you for following me, sharing in LinkedIn, and comment, like, whatever you want. Let's go ahead with the next video next week.